All right, today we're putting on our detective hats. We're going to piece together the epic story of our planet by following a trail of clues that have been left behind for millions and millions of years. I mean, think about it. It's the ultimate cold case, right? There are no eyewitnesses, no security cameras, no written records. So how on earth can we possibly know what was going on before humans were even around?
Well, it turns out the planet tells its own story. The evidence is literally all around us. It's written in the rocks, in the fossils, and in the very shape of the continents themselves. So let's dive into this investigation.
So where do we start? Well, our first clue is actually hiding in plain sight, on something as simple as a world map. For centuries, people kind of noticed something was off, but it took a really bold mind to see it not just as a coincidence, but as evidence of a planetary-scale mystery.
And this brings us to our lead detective, a German geophysicist named Alfred Wegener. In 1910, he looked at that same world map and came up with this radical idea that the continents weren't fixed in place. No, he argued they were adrift, that they'd broken apart from this one single massive supercontinent he called Pangaea.
Wegener's case was built on a mountain of solid evidence. He had this great analogy. He said it was like refitting the torn pieces of a newspaper. Not only would the edges have to match, but the lines of print, things like ancient mountain ranges and fossil deposits, they'd have to line up perfectly across the tear. And when he looked, they did. He found identical fossils and matching rock layers on coasts that are now separated by thousands of miles of ocean.
But, every great detective story needs a good plot twist, right? And Wegener's was a big one. For decades, pretty much nobody believed him. The main hang-up was that he couldn't explain how. How could giant continents possibly plow through the solid ocean floor? It just didn't make sense. It took about 50 years and brand new sonar technology from the Cold War to finally map the seabed and find that missing key. And this quote, wow, it just perfectly captures the pushback he got. The scientific community at the time basically felt that if they accepted Wegener's idea, they'd have to tear up all their textbooks and start completely from scratch. It was a massive revolution in thinking. And revolutions, well, they're not always popular at first.
And then, finally, the revolution came, the theory of plate tectonics. This was the missing engine Wegener was looking for. See, it revealed that the continents weren't plowing through the ocean floor. They were basically just passengers on top of it. Earth's crust is broken up into these massive, rigid plates that are constantly moving, driven by the intense heat from the planet's core. And just like that, this became the unifying theory for pretty much all of geology.
Okay, so Wegener gave us this incredible idea of a shifting stage. But what about the actors in this grand play of Earth's history? For that, we have to turn to our second clue, the planet's own eyewitnesses, which have been perfectly preserved for us in stone.
Just take a look at this. I mean, at first glance, it looks like some kind of stone column, right? But that was once a living, breathing tree. Petrified wood is one of the most incredible forms of fossilization. It's basically a perfect, three-dimensional rock replica of life from a world that's long gone. So how in the world does wood turn into solid rock?
It's a pretty incredible process when you think about it. The secret ingredient? It's got to be rapid burial, usually from something like volcanic ash. That seals the wood off from oxygen, so it can't rot. Then, over millions of years, water full of dissolved minerals seeps in and works its magic. It replaces every single organic molecule, one by one, with a mineral one, until what you're left with is a perfect stone copy that preserves the tree's structure right down to the cellular level.
And here's the crucial point. These fossils, they are so much more than just pretty objects to look at. They're the data. They are the hard, physical evidence that supports one of the most important ideas in all of science, the theory of evolution.
And of course, it was Charles Darwin who gave us the how behind all this incredible change, natural selection. It's actually a pretty simple but incredibly powerful idea. In any given environment, some individuals will have traits that give them a little bit of an edge, and because of that, they're more likely to survive and pass those winning traits on to their kids. Now, you stretch that process out over vast geologic time, and you get entirely new species.
And this is where our clues really start to snap together. Fossils show us the whole history of life, including these amazing transitional creatures like Tiktaalik. People call it the fishapod, which helps us see the jump from fish to land animals. And get this,
Finding the exact same land animal fossils on continents now separated by vast oceans, that was one of Wegener's key pieces of evidence for continental drift. It all connects.
Okay, so we've got a moving stage and we've met the actors. But what's the engine? What's powering this whole production? For our third and final clue, we need to look deep inside the Earth at the planet's internal engine and the spectacular and sometimes terrifying way it shows its power.
It's wild when you realize that the exact same forces, those huge convection currents deep in the mantle pushing the continents around, are also what fuel volcanoes. They create these intense hotspots and weak points in the Earth's crust, especially right where the tectonic plates are crashing into each other or pulling apart. And when all that unimaginable heat and pressure finally breaks through, you get a volcano. It's the most direct, most dramatic expression of the planet's inner power.
And that power, it can be absolutely terrifying. The 1902 eruption of Mount Pelée is a really stark reminder of that. It sits right on a tectonic plate boundary, and in just a few minutes, its eruption unleashed a force that killed almost 30,000 people.
And this is what was left of the city of St. Pierre. The destruction was so complete, so unbelievably fast, it just baffled scientists. This wasn't some slow-moving lava flow. This was something else entirely. A new kind of volcanic threat that showed just how little we really understood these tectonic forces.
What they were seeing was something they called a nuée ardente, a glowing cloud. Think of it as a superheated avalanche of ash, rock, and gas that blasts sideways out of a volcano at hurricane speeds. It is a direct and brutal consequence of the specific geology at that plate boundary, a demonstration of the engine that shapes our world.
You know, figuring out how our planet's engine works, it takes some serious bravery. I mean, listen to this. During a later eruption, a volcanologist named Frank Perret actually set up an observation post on the slopes of the active volcano itself. His work wasn't just about understanding one mountain. It was about trying to decipher the fundamental rules of the forces that move our continents and build the very world around us.
Okay, we've gathered all our clues. The drifting continents, the fossil eyewitnesses, and that fiery engine deep inside the Earth. Now it's time for the big reveal. Let's piece it all together and solve this thing.
And when you lay it all out, you see it's not just a bunch of random facts. It's one single, deeply interconnected story. Plate tectonics moves the continents around, and that changes the environment. Life then evolves and adapts to that new environment. And the fossils, they're like the script, recording that entire process for us to come back and read millions of years later.
So things like geology, paleontology, biology, volcanology, they aren't separate sciences. Not really. They're just different chapters in the exact same epic story. Every single clue informs all the others, building this richer, more complete picture of our planet's incredible history.
But here's the thing. This great detective story, it isn't over. It's still being written. Right now. The continents are still moving, life is still evolving, and that internal engine is definitely still running. The clues of our present moment are being laid down as we speak, which leaves us with one final question to think about.